Thanks for coming down to this session. My name's Sunil. I'm going to be talking to you today about continuous delivery with DCOS and Jenkins. So how many people here have heard of Jenkins? OK, good. How many people here like Jenkins? Oh, OK. That's a reasonable overlap. That's good. And how many people here have heard of DCOS? My colleagues put their hands up, but OK, hopefully we can teach you a bit about that today. Have you heard of Apache MESOS, anyone? OK, that's more. So I'll talk a bit about how DCOS relates to MESOS, which might be a question some people have. If you have any questions throughout, let's just put your hand up. We'll answer them as we go. The plan today is to go through a bit of a presentation that should take about 30, 35 minutes. Tell you a bit about all the components here. There's a lot of information to take in, so these slides will be available afterwards. You can come ask us for any clarifying questions you have afterwards, and just try to make the most of it. I'm going to try and simplify what we actually go through in the workshop part of this session to things that are sort of highlighting interesting parts of running an application on DCOS. But there's likely to be some new stuff there, and so if you get stuck, raise your hand. We'll try and help. I have a couple of colleagues here from MESOS who will help out during the workshop section too. So Carl and Ravi here at the front. Cool. So just to sort of come at this top down, the part of MESOS I work in is called developer agility. And our goal is basically to help developers get their applications to production much more easily and quicker. This is using MESOS and DCOS. DCOS is our product. And that helps you do a number of things, from shipping your product and getting it in front of customers quicker to actually fixing bugs quickly. We want to make it as easy as possible for every organization to work at a similar cadence to companies like Google and Facebook. So you'll see this diagram again later in the slides. This is what we consider to be a continuous delivery pipeline. It's a very simplified view of what that is. But on the left here, you have a user. The user pushes some code. It goes up to a version control system of some sort. Kicks off a build, some tests. That puts some artifacts somewhere. In our case, we're primarily focused on containers. So we've got a container registry here. And then we hand off to some sort of orchestration engine, which will go and place it for you on some production infrastructure. Deploy it to some production environment, and then your users, hopefully, if you've set up things correctly, don't see any downtime when they query your website, whatever service it is, via hopefully some sort of load balancer or some sort of service discovery mechanism. And within some matter of time, you have a completely automated way of deploying something to your users. So this should all happen seamlessly. And so what we're going to do in the workshop today is actually set up a very simple version of one of these, but hopefully touch upon the components you need to do this on your own infrastructure. OK, so let's talk about MESOS and DCOS. So this is a quick introduction to containers. How many people here have used or know a little bit about containers? OK, so you're all pretty familiar. For people who haven't heard about containers or haven't used them before, a nice way to think of them is to compare them to virtual machines. So typically, if you had a virtual machine-based infrastructure and you were deploying your applications to it, you would run a series of virtual machines on physical servers. In this example, we have 2 virtual machines running on 2 physical servers. So we have 4 virtual machines. And then you run one application inside each virtual machine. And that gives you this nice benefit of isolating each of the apps from each other. The caveat is that it's very heavyweight, because you're basically simulating an entire machine for each one of these applications. So with containers, we try and do something similar. We try and ensure apps are isolated from one another. But we do that by essentially using primitives based into the operating system. So the isolation is not as strong. It's more resource-based. But for the most part, that's good enough for most apps. And that lets us fit more things onto these machines, because there's not so much overhead in terms of getting them deployed. There's no emulation taking place. We're not physically emulating another computer. But we're also able to run things side by side without actually my app taking down someone else's app. Another way to look at it is if you look at virtual machines versus Docker containers versus C groups. And C groups here is kind of similar to what MESOS used to do in the early days. MESOS now supports Docker containers. The way to think of Docker containers, in my mind, is more like an image format. So, your canonical unit before with a virtual machine was a virtual machine image. And that image would include a guest operating system, all the dependencies your application needs, and the application. And that's pretty sizable. With containers, we do something similar, except we try and reduce the amount of things we have to ship with the container. So in this case, we're shipping the dependencies of the application. And so, for example, if you were running Nginx, the dependencies here would be any system libraries that Nginx needs to use. Same with Python. If you had an application that was using Python 3.4, you would ship Python 3.4 in your container image. That's kind of nice because it means your application is now portable. So you get the same benefit of having a virtual machine. You can move this container around, but you don't need to include a full operating system in there. So typically, a Docker container would run on top of a host operating system. So there is slightly less flexibility there, but it means your container image is a much lighter weight. On the right here, the Linux cgroups approach is basically the same thing, except we don't bundle the dependencies with the container. So we isolate the container in a very similar way to a Docker container, but there's no assumption that dependencies are actually in the container image itself. Okay, so we'll talk a bit about Apache MESOS and then talk about DCOS. Both of these are open source projects. DCOS is one that I guess we've been driving at Mesosphere. Apache MESOS is an Apache project. It started off as a university project, became a top-level Apache project, is used at a lot of companies. The contributors to that project extend far beyond Mesosphere. So starting off with MESOS, what is MESOS? MESOS is a cluster resource manager. And this is quite an academic concept, but one that is actually quite useful when you are running stuff in production, particularly if you're running lots of services in production. Because when you go beyond running just one application on 100 machines, where it's the same artifact on every machine, you need some way to basically deploy those applications to those machines and manage what percentage of the cluster or what resources they consume. A naive way to do it is to say, I have 100 machines. If I have 10 applications, each application gets 1/10 of the cluster. That doesn't really work because it's not often the case that each of those applications requires the same amount of resources. So MESOS steps in and tries to model resources at a finer grained level. And we're not going right down to the individual CPU cycles your application needs, but we do it at using 3 high-level primitives, or 3 high-level resources. One of those resources is CPU shares. And what this means is, I guess the way to think about it is, if I have 1 CPU share, that means I get roughly 1 CPU's worth of time. So if I have a 4-core machine and I ask for 4 CPU shares, theoretically I should get the entire machine. You can do all sorts of things to oversubscribe that, so you can change how that works. But for the most part, think of it as 1 CPU share maps to 1 CPU's worth of time. Memory is a little more straightforward as is disk. You ask for a number of gigabytes of memory, a number of gigabytes of disk, and we get those from MESOS. So what MESOS does is it takes this information across a set of machines and then represents all of them as one single entity to any application running on MESOS. So if I was running against MESOS, I would not be concerned about the number of nodes in my cluster. I would just be looking for resources. I have an application to launch. I know my application needs this much CPU. I know I need to run 10 instances of it. And I would just run those on MESOS. I wouldn't care about whether the cluster had 100 nodes or 1,000. MESOS would take care of that for me, which is nice. So these applications running on top of MESOS we call frameworks. And that's a heavily overloaded term. I'm not going to delve into that too much, but just know that in MESOS land we call them frameworks. And MESOS works at scale. So one of the reasons we exist as a company right now is because all of these other tech companies have actually had great success using MESOS. Caveat is that MESOS is, at least when we launched, was non-trivial to set up. We've made that a lot easier, but DCOS is, to some extent, why we exist as a company, because MESOS is tough. So we want to make that much easier. DCOS makes that process of installation and configuration much more easy. So MESOS has this idea of 2-tier scheduling. I won't go into that too much, but the idea is that MESOS doesn't know how your application wants to deploy itself, right? So if you're deploying a very simple application, that's easy enough, right? I have 10 instances of this application. I want to run 10 of them. MESOS will go and run 10 of them. Other sort of applications, though, like you're not running web services on all of your hardware. You're running databases. You're running distributed systems like Kafka. You don't just want to scale those in a very specific way, right? I think Hadoop is the best example of this. You want your Hadoop nodes to run on nodes where your data is. So you want to optimize for data locality. So what we do there is basically allow Hadoop to define its own scheduler. And that scheduler will go and tell MESOS where it wants to run its things. That becomes quite powerful when you're sharing different types of applications in the same cluster, because you can get very, very fine-grained resource efficiencies. So I can say, hey, Hadoop should run on these nodes. My web application should run on these other nodes. Every scheduler makes its own decisions, and they are optimal for that application. But across the entire cluster, MESOS is able to schedule things at a lower level, which balances things out nicely. So that's a bit of a mouthful. I recommend reading the MESOS paper if you are looking for something to read on the plane ride home. It's actually quite an entertaining paper as far as academic papers goes. It's quite easy to read, so recommend that. OK, so a few other facts about MESOS. MESOS is highly available, which is great, because you're running 10,000 nodes on it. You don't want the system that's running all those nodes to go down. The agents are fault tolerant, so you could take the masters down, your applications would still run. You can take the agents down, MESOS would still be scheduling tasks somewhere else in the cluster. So that works really well. You can also do rolling upgrades, which is nice. The people at Twitter actually developed this because they had this problem once they had a few thousand nodes running MESOS, where they couldn't just take the nodes down. You don't have a spare 2,000 nodes to migrate your applications to when you upgrade MESOS. So they had to make sure it was possible to upgrade MESOS in place. I mentioned the resource isolation earlier. So we use C groups. Docker is also supported. And you can write applications for MESOS in many different languages. So it's written in C++, but we have bindings for Java, Python, Go. And recently we released an HTTP API, so you should be able to just, anything that can speak HTTP can write to it. OK, so here's a more complicated diagram. This one shows you how MESOS looks. So I mentioned this idea of MESOS masters. Typically, you'll have more than one. MESOS master resource consumption scales linearly with the amount of tasks running on your cluster. So typically, you will always have one master in charge. But as you get more and more things running on your cluster, you just have a bigger master. You also have an odd number of these things running in a quorum, so that if one of these things goes down, the other two can vote in between them who should be in charge. Big clusters will typically have multiple masters. So three masters is sort of bare minimum for HA. If you wanted to run 5 masters, 7 masters, that would probably be desirable in a big cluster. We have our agents. The agents are actually running our tasks. And we have this idea of an executor too. And I won't go into that too much. And then we have our frameworks who schedule things on top of MESOS. So MESOS is basically, in this picture, taking the resources available on each machine. So in this case, we say 16 CPUs, or 16 CPU shares, 128 gigabytes of memory, 1 terabyte of disk. It's cataloging those and then offering them to these things that want to schedule tasks on the cluster. OK, so once you start running things on this sort of infrastructure, you run into a number of issues, one of which is service discovery, right? So as I mentioned, previously you'd run 10 instances of your application on 10 machines. That's easy. You can hard code where those machines are. You can say, OK, these 10 machines are running my application. When we get to MESOS land, you tell MESOS to go run your application, and MESOS will go run it somewhere for you. But you don't know it's going to run where it's going to run. It may run on node 1. It may run on node 80. And you don't really know how to look up that application, how to plumb that into the rest of your infrastructure, and so on. So that becomes a hard problem. So we have a number of projects that actually tackle this. MESOS DNS is one of them. You can also use console with MESOS. And we have another project called Marathon LB, which does that too. Once you have containerized infrastructure, another issue you run into is how to monitor your stuff. So there are a number of projects that do this. Do you use Nagios? Do you use Prometheus? Do you use Snap? Snap is an Intel framework for telemetry of containers. There's a lot of options there. Storage, again, similar issue. Ceph is a popular system in this world. HDFS is another one. If you're running on the cloud, you have Amazon. You also have a way, you may want to use NFS if you have some legacy applications, Cassandra, and so on. And I think this is very similar to the first one, but it's how do you manage all of these things running all over the cluster? How do you know where your application is being served? And how do you keep updating the necessary records and so on so that you can route to your application? So DCOS was kind of our answer to this. What we did was we took some of the recommended approaches that many of our customers were starting to use and rolled it into one distribution, which makes it very easy to install and deploy these things together. And so what we'll be using for the demo today is, or the workshop section, is DCOS. DCOS includes MESOS, so everything you see today you can do on MESOS yourself. It will just take you a bit longer to set up and install it. So DCOS includes security components, multi-tenancy components, networking, storage, all that sort of stuff. And then we have this idea of a service manager. And so the service manager here is like the scheduler I mentioned previously. So what that's doing is you are telling it what to run, and then it goes and schedules it on MESOS for you. You can run multiple things via that. So you can run frameworks. That's perhaps a bit overloaded. Data services, I think, is more accurate. So things like HDFS or Cassandra. And those things will actually go and run natively on your cluster for you. You can also just run any sort of Docker container or a MESOS container using Marathon, which is nice. And so DCOS is a really nice way to share your cluster amongst all of these workloads. One of the benefits of, or one of the reasons our customers come to us sometimes instead of using other container orchestrators is because MESOS does a better job of orchestrating these data applications as well as traditional containerized applications, which is nice. So I think I mentioned all of this. We have a bunch of extra stuff built in. DCOS is all open source. It strings together a bunch of open source projects, so you could replicate this yourself if you wanted to. Cool. So let's get to the reason probably a lot of people are here. Jenkins on DCOS. So I wasn't using Jenkins in 2004 when it launched, but this is how I'm told it went. So in 2004, you had one Jenkins instance, perhaps, and you'd run all your builds on the Jenkins master. And that's very easy to manage. You go in, you install your dependencies on that machine, nice and easy, no issues around contention. You don't need to set up any additional hosts, very straightforward. But it was almost too useful, because what happens is more and more people start to use Jenkins, and suddenly you need to distribute the work that it's doing. So we see this often amongst people who are running large Jenkins deployments, where if you're in a large organization, every team has its own Jenkins cluster. And I don't really know how this happens. I mean, anecdotally, when I was at my last company, our Jenkins instance ran out of capacity. We had a spare desktop because one of our devs had left. I took his desktop, hooked it into Jenkins, and suddenly we have a Jenkins cluster. That's not optimal if you're a big company, though, because suddenly you're running a bunch of instances all over your environment, which are basically running Jenkins and often not being fully utilized. So that costs something. It becomes hard to manage it. You rely on teams themselves to upgrade Jenkins. You may be running unpatched version of Jenkins. You basically have very little coordination across all of these instances. If you're more advanced, you have some automated way to provision Jenkins. There's some way to expand these, but it's still not very efficient because teams are often really bad at estimating how many resources they need. And so in this example, you may have a team that is doing things properly, a team that has too many agents and is not using them, and a team that has just one agent and is really struggling because they have a lot of devs, and you're wasting a lot of time. So what we do is we stick DCOS in the middle. And this mimics an approach that eBay and PayPal, back when they were one company, pioneered. And there's a very good blog post about this. If you look up eBay, MESOS, and Jenkins, you'll see the blog posts. What they do is they basically use MESOS. In our case, we're using the DCOS version of MESOS to actually run things. So Jenkins is scheduling applications on MESOS, so it connects to the DCOS master. Whenever there is work to be done, it actually goes and creates a new build agent running in a container. That container runs your build, and when that container finishes, it terminates. And the termination here is crucial because it means you don't have a statically configured pool of Jenkins agents. The only thing that is static here is your DCOS agents. When you have multiple Jenkins frameworks, this works really well because when one of those frameworks has no more work to be done, the other masters basically come along, run builds, and they are unblocked. So this is really, really cool because eBay used it to go from 2,000 virtual machines to 200. So a factor of 10 decrease. It's quite incredible. CI maps really, really nicely to the MESOS scheduler use case. Cool. OK. So this is basically going back to that initial point I said about developer agility. So when we look at what our customers are doing with environments before using something like DCOS, so stuff that is very, very legacy, I guess, for lack of a better term, they basically spend a long time getting their application from planning their application or whatever project they're doing, figuring out where to run it, configuring those resources, and then going through this very manual process of promoting it from environment to environment, and then actually getting it in front of their customers. So our goal with DCOS is to make that much quicker. Weekly is desirable. So we took this diagram and showed it to one of our customers in banking, and they looked at it, laughed, and said, OK, you just have to replace week with month. And so even going from 9 months to 1 month for them is a significant time saving. So I'll just go quickly through some of the features that we have on DCOS to actually tell you, to show how you can make this a reality. And then we'll try and use it and do the same thing. So in terms of scheduling, this is just comparing what you would have done before with how you'd now do it with DCOS. So I mentioned this a couple of times. Before you had something like DCOS, you would actually go and provision a set of machines and host your application there. With DCOS, MESOS handles that for you. So you tell something like Marathon, which is our container orchestrator, that you want to run your application, and it will go and figure out with MESOS where to run it for you. When you deploy applications now, so before you had DCOS, you would have some sort of, you either did it by hand, or if you were savvy, you would use something like Puppet or Chef or Ansible, or Jenkins SSHing into the machine and running a shell script. So it was a very manual process, kind of brittle. With DCOS, again, your container orchestrator takes care of that. So we have this thing called Marathon. Marathon will basically run the deployment for you. You also package your application and the dependencies with the container so that you don't need to worry about getting dependencies onto the nodes either, which makes it much easier. OK, so health checks, you'd have Nagas. It would page a sysadmin. They would get woken up. Their personal life may suffer. With DCOS, ideally, Marathon is configured to perform health checks on your instances. If your application becomes unresponsive, it knows how to restart the application for you. So theoretically, you get woken up fewer times. If a node goes away, the health check picks that up. Marathon will then scale your application or continue to maintain whatever number of instances you configure, so that it's always running the required amount of your required instances of your application. Service discovery, as I mentioned, before you would have some sort of config management tool, or you would use a spreadsheet. That works well enough when you are manually installing things on machines, and you configure everything manually. Now it's a bit more difficult to do that because your application may run anywhere. So we provide a number of services to do that. So MESOS DNS creates DNS records for your application. And then we have some utilities that basically rebuild load balancer configurations. So if your task moves from node 80 to node 1, we have some utilities that will basically reload HA proxy or whatever for you so that your application is always being served. Cool. Persistence is an interesting one. I don't think we've quite got to a good state there yet, but we're getting there. Historically, again, everything was very manual. You'd configure some sort of storage area network and some sort of static file system that would go and be mounted on each one of your nodes. Now we have essentially this idea of a storage engine, which will go and request volumes for your applications as you need them. And we can automate a lot of that. So as your application moves around, it can move the volume around with the application too. So you no longer need to statically mount a file system onto each one of your nodes. We also have more interesting distributed file systems like Ceph coming soon. And Ceph on MESOS would be a really interesting way to basically, again, migrate your data or ensure it's redundant and available to each of your nodes wherever your application is running. Cool, OK. That actually went quicker than I thought, which is good, because now we get to do the fun stuff. So what we're going to do is actually, I have a couple more slides. We're going to do a workshop. So what we're going to do is build this pipeline. This is my version of the diagram you saw at the beginning. Perhaps less graphically pleasing, but I'm proud of it. I made it. And what we're going to do is basically hook up a Git repo to Jenkins running on DCOS. We're going to push a Docker image somewhere, and then we're going to kick off a deployment and actually run it on DCOS. So in this diagram, Jenkins is the thing I've mentioned multiple times. Marathon is our container orchestrator. MESOS is the production environment. And then we use a tool called Marathon LB to actually serve our application. So Marathon LB here is a HA proxy-based load balancer. I've already configured it on the machines for you. It's very easy to set up and run, but it makes it easy to expose your application to the internet. And we'll be doing that at the end of the tutorial. So we'll be running an application and then making it public. In our case, we're going to use GitHub and Docker Hub to actually run, or to store our code and to store our Docker image. This is purely for simplicity. You can also run, we don't have GitHub on DCOS, but you could run GitLab on DCOS if you wanted to. You can also use DCOS with things like the ECR container registry or GCR, or any of these cloud-based registries. But we use Docker Hub for simplicity here. OK, so before we dive into the tutorial, I just wanted to highlight 3 things here, 3 files. And so this is the way I think of continuous delivery. There are undoubtedly many different approaches. But what I like to do is ensure these 3 things are checked into my code repo. And they basically tell DCOS, Jenkins, and I guess Docker how to build, run, and deploy my application. So the Jenkins file here is a Jenkins 2.0 concept using this thing called pipeline. And the Jenkins file basically lets us use a script to say how our job is built, or how our Docker image is built, or our application. You could also run tests, do anything else that you would normally do in Jenkins from the UI. But this is a script that you can check in with your code. That has a number of benefits. One is that you don't have to actually worry about the build becoming out of sync with what's in the code base. So if you change the build, you can just change the Docker file, the Jenkins file in the repo with whatever changes you've made. And theoretically, everything just keeps working. Very easy to see changes to the Jenkins file, like what happened to the build when someone changed it, why did it break now or last week. Very easy to do that sort of thing. The Docker file tells Docker how to build our application. You've probably all seen that before. It's quite straightforward. And the Marathon JSON is a JSON file that tells us how to run our application. So we'll go through that later, but it basically specifies resources the application requires, what artifacts to run, how to make it open to the public, and so on. Cool. OK, so let's dive in. If you could bring up github.com/mesosphere/software architecture in your browsers, and we'll get started. So what I did prior to this starting was I pinned numbers up. So basically, if you're sitting on that side, pick the number closest to you on the wall. If you're on this side, pick the number on this side closest to you. With the exception of the middle row, you've got I think you have a number 5 on the table. Yeah. If you're in the middle here, I think I put the numbers down here. So these first 2 rows on this side are number 8. On this side, first 2 rows number 7. And then back here, I think we're number 9 and number 10 here. So what we're going to do is use those to actually distribute you amongst the clusters that I have set up. So if we go to the README here, you'll see that there is a list of 10 clusters. So just use your number to figure out which cluster you want to use. If you see that a lot of people are using one of the clusters, like I think 9 and 10 are going to be quite congested, feel free to pick one of the ones off the wall, because I think it's a bit quieter on the sides there. So once you have that number, you'll need these credentials, so SA user and SA pass, the username and password for each of these clusters. So you are sharing these clusters with other people. I'd recommend not deleting anything that isn't your own. And you also have super user access, so just be careful. You could potentially break something. Hopefully that's not possible, but just be a little bit cautious. So each of these clusters have a number of agents. So let's have a look. Okay, so this is what the DCOS UI looks like, and you'll see that we have. So in this case, we have 24 CPU shares and 82 gig of memory in total. And I'm not running very much on here besides Jenkins and Marathon LB. So what we'll do first is I will break for a couple of minutes to let you sign up for GitHub if you don't have an account already, and play with the DCOS cluster. So exercises 0 and 1 will have you just play with the UI and set up the DCOS CLI on your machine. So this is a command line tool that we'll be using for the rest of this tutorial to interact with the cluster. When you're installing the CLI, this is an issue people have run into repeatedly, is that we don't have verified SSL certificates on each of these machines. So you'll get a warning when you try and install it. When you get that warning, it will spit out a message saying, run DCOS config set core.ssl verify. So just paste that in, run it, and set the value to false, and then you should be all set. And then you can try and check that it's working by running things like DCOS Marathon app list, which I will show you. And you should get something like that. No, I need to do auth login. Okay, let's try again. Cool. So you'll see that I have a couple of applications running, and you should see something like that on each of your own clusters. So let's break there, have a play with the user interface. I would recommend not installing anything from the universe just because we don't have too many nodes in each of these clusters, and sometimes each of these packages take a few CPUs or a few gigabytes of memory. We might run out of space. But yeah. Let's break there. If you have any questions, raise your hand. Myself, Ravi, or Carl can help you out. We'll come over and help you. Okay, so I'm going to pick up again there. So hopefully by now you have had a bit of a play with the DCOS UI and managed to get the CLI installed. Is anyone having difficulty with that? Okay, cool. So I'm going to run through the next couple of steps with you. And let's do this. So next what we're going to do is create a GitHub repository. So this is really just to isolate your files from everyone else's. Typically, my assumption here is that the repository contains everything we need to deploy. For this simple project, that makes sense. This may be more complicated for more extensive projects. But for now, this will do. So I'm going to create a new repo here. We'll call it software architecture. And if you look through the examples, I actually just use my username and this repo, which means they will probably work for you. But I would recommend, if you don't see the results you intend, just double checking that you've actually used your own username in place of mine. Otherwise, it might not work as you intend. Cool. So I have a very simple repo, and I'm going to check that out locally. Okay. Where am I? Okay. So let's create this one I had from earlier. Let's clone that. Okay. So I'm in my repo now. The very first thing I'm going to do is create a very simple Docker image. And so what I'm going to do here is use Nginx to serve a hello world page. So the first thing I do is create my index page. So stick that in index.html. Exit. Next thing we're going to do is create a Docker file. So the Docker file basically tells us how to package the application. A Docker file to Docker is a bit like make. You're essentially giving a set of instructions that say, hey, this is how I want my application to be assembled. This Docker file is very simple. We've got two commands. We say extend from the Nginx base container, so from Nginx, and then copy the file index.html, which is in the local directory, into this path in the container. And that's pretty much it. Again, this is a very naive application. You can do all sorts of other interesting things here. For now, we're just copying a file into the container, and then that's it. Paste that into Docker file, and save it. So if you want, you can actually test this locally. So we're going to run the docker build command. You will need Docker installed on your laptop if you want to do this. If you don't have it installed, then this will not work. So I do a docker build. And -t here is telling it to tag it with mesosphere/software architecture. And the full stop here is saying use the Docker file in the current directory. And you'll see that it's actually just running those commands in sequence. So step 1 is the from, and step 2 is the copy. And we built a new container image. So now I can actually go and run this. And what we should see here is that, let's see, I think that's up. It's serving hello world on my localhost address. So with that run command, we basically bound port 8080 on my machine to port 80 on the container. Cool. OK, so our Docker image works, which is good because it's very simple. Now we add those files to git, commit, and push. Cool. OK, so now if I go to my new GitHub repo, we'll see that we do have those two files and a README. Very, very simple. OK, so that's the application. Now we need to actually set that up in Jenkins. So I mentioned we're using this Jenkins pipeline feature. And what we're going to do is create a file called a Jenkins file. And we're going to add this Groovy script to it, and commit it, and then configure Jenkins to use it. So Jenkins file. OK, so let's run through this script very quickly so you know what it's doing. So again, I recommend changing the username at the top to not use my username. This is so that we can namespace the images that are pushed to Docker Hub. We don't want images to overwrite each other. So change that. We have a utility method here that gets the git commit of the current commit that we've checked out. And then the node stuff here actually represents all the steps that we run on a single node within Jenkins. So you could have multiple nodes. I haven't tried this, but there is a way of essentially running things in parallel, running things on multiple nodes. And we have these stages. So the first stage here is to just check out the repo itself. Then we build the Docker image. And so what we've done with Jenkins on DCOS is make it very easy for people to run Docker build commands and Docker run commands, anything you would usually do with the Docker CLI from within your job. How we do this is a bit more interesting and probably a topic for another talk. But if you have any questions, we can talk about that afterwards. So we do a Docker build. And when we do the build, we actually use these variables here. So we use the username variable, which we've specified at the top here. And we use the git commit here, this method, which will actually return the current git commit. And so what that means is when we build this image, we basically tag it with my username and the git commit. What we then do later is publish this image. So we use this credentials block here to bind credentials that I've already configured in Jenkins for you that have the permission to actually write to this Docker Hub repo. What we then do is we use those environment variables to a Docker login. And then we do a Docker push. And again, we're using the same tag here. So we're using the same tag to build, push, and then later we use that tag to actually deploy the application too. Cool. So very simple. I'm not going to make any changes because that is my username, but I recommend you change it to yours. Close that. And again, we will add the Jenkins file to Git, commit it, and then push it. Oops. Cool. OK, so the next thing is to wrestle with the Jenkins user interface. Pipeline makes it much easier because you just need to specify one thing. So yeah, let's see. Oh, sure. OK, yeah. So let's pick up again in 5 or 10 minutes. Raise your hand if you get stuck. OK, I'm going to set up the pipeline job in Jenkins itself. And then I'll break there again and let people catch up. So once you have those files checked into GitHub, so again, this is our repo. If I refresh this, you'll see we now have a Jenkins file. We then start to actually use DCOS. So what you'll find if you go to the services page is that there are 2 services already. So we have Jenkins and Marathon LB. We'll come to Marathon LB in a couple of exercises time. And Jenkins here is what we're all going to use. So you'll be sharing Jenkins with everyone else who's using your cluster. You don't need to install your own one. So if you click on this little arrow thing, it'll bring up the Jenkins dashboard. And I guess someone is already running something on my Jenkins instance, which is great. So what I'm going to do is create a new item, create a pipeline job. And I recommend calling this nginx - whatever your name is. You can call it whatever you like, really. You just want to make sure it is not the same as anyone else's. Hit OK. And we just need to specify a few things. So the first is how often it should be triggered. And what we'll do there is very naively tell Jenkins to poll our source control repo every minute. This is something you probably don't want to do for a production Jenkins instance, but we're going to cheat here and just use it as a shortcut. And the second thing we need to do is select that pipeline script. So we'll say pipeline script from SCM. And what Jenkins will do is actually check out the Git repo, look for the Jenkins file, and then run that build. So what we do here is we say use Git as our SCM. And then I'm going to clone it. I'm going to use the HTTP URL. This will save me from having to set up keys and so on. So I don't need to put any credentials in here. My repo is public. If your repo isn't public, you may see an authentication error when the build runs. And that's it. So a very simple configuration here. I'll hit save. And what Jenkins will do is it will run, within a minute, it will trigger the first build because it notices that it has never run before. And you should see a build get queued here. So what's interesting here is Jenkins, I mentioned this idea of Jenkins spinning up agents automatically on DCOS. What it's doing here is exactly that. So there's only one agent here. If I was to go and run this job again and run my job in parallel, what you'd see is Jenkins will actually go and spin up an additional executor on DCOS. So although it looks like that ran quickly enough, it didn't have to. Let's see. OK, so this is all the tasks that Jenkins is running. This is the Jenkins master down here. And these MESOS tasks are ones that it is spinning up dynamically. It looks like those ran quickly enough that it didn't have to. But I could actually go and delete this agent and run another build. And you'd see that Jenkins is spinning up agents in response to the stuff in the build queue. Yeah. OK. Let's see. OK, so it is queued. And then you'll see that Jenkins will spin up a new agent. That'll show up here. If we go look at the dashboard, so you see that little jump down where the agent was terminated, where I terminated it. And then we've got this bump up again where Jenkins launches a new agent. And if we had tens of builds in the queue here, you'd see more of this staircase pattern on the graph. OK, so that build ran successfully. If we look at the stage view here, you'll see that it ran all the way through to deploy. And then if I go to, oh, that's interesting. I didn't add a deploy step, or did I? Curious. Anyway, if we look at the Docker Hub repo, refresh this, you'll see that actually it looks like a lot of you are at this stage already, which is great. We have a bunch of tags here. So here I see my SSK2 one along with the git commit from that build. Cool. So that takes us up to the end of exercise 4. I will pause there for another 10 minutes or so, and then we'll continue on. Okay, I'm going to show you the next step of the tutorial, which is the actual deploy, and then we'll break again there. We've got about 25 minutes left, so I'll probably just show you the next tutorial on the next exercise here, and then leave it to you. So I'll be around until sometime after 12:15. So feel free to just put your hand up, work through the rest of the exercises after this, and go from there. So the next thing we're going to do is add a deploy step to Marathon. So as I mentioned, Marathon is our container orchestrator. And what we're going to do is use a plugin that we have developed for Jenkins that makes it very easy to add a deploy step to your pipeline. So the first thing we need to do is tell Marathon how to run our application. And that's what we use this thing called the marathon.json for. So what we do is we take this JSON blob, save it into the repo, new file, marathon.json. This JSON file describes how to run our applications. So ID, pretty self-explanatory. Number of CPU shares we want, 128 megabytes of memory, one instance, and then crucially the Docker image. So this is saying, hey, I want you to run this Docker image. In this case, we're using that image on Docker Hub, and we're saying latest here, but we're actually going to overwrite that tag when we go to do the deploy. We give it some other information, like what ports to expose. So in this case, we're saying expose port 80. We specify a health check, and this is that mechanism I mentioned earlier that will stop you having to wake up your operations staff in the middle of the night because an application has become unresponsive. Marathon will basically hit this endpoint, so it will do a GET request against slash. And if that fails 3 times in a row, then it will fail the application, consider it unhealthy, and then delete it or kill it and then restart it somewhere else. And then finally, we have some metadata about the application, which tells DCOS how to make it available to users of the DCOS cluster. So in this case, we're saying the service name is nginx-ssk2, and it will make the service available at /service/nginx-ssk2. So I recommend renaming that to your username and renaming the ID up here. The rest of it we will overwrite when we deploy it. So I'm going to take that JSON blob and create a new file, marathon.json, paste it in there. I don't need to change anything here because that's my username, but again, I recommend changing that. Write it. Cool, so that's the marathon.json part. That tells Marathon how to run it, but now we need to actually change our build so that Jenkins can tell Marathon to kick off a new deployment. So what we do here is we add a new stage, we call it deploy stage, and we have this new method we call Marathon. This is what our plugin provides. So we configure the URL, which is which Marathon to deploy to. In this case, we're using the one that is built in with DCOS, so we say marathon.mesos. And this syntax here is using Mesos DNS. So I don't actually need to know the IP address of where Marathon is running. It will go and resolve that automatically for me. I pass in some credentials. This lets us actually kick off a deployment. I've actually gone and created tokens for everyone's clusters here, so you don't need to do that manually. I also specify a file name. Again, by default, we assume it's marathon.json, which is what I've just saved. We'll give it the app ID, so we can overwrite that when we go to deploy. In this case, I'm using that username variable again. And then we also overwrite the Docker image. So this is how we're sure we are always deploying the same thing that we've built. We, again, use the username and the git commit. So this is identical to what we had in the build and the publish steps earlier. So I'm going to grab that chunk, and I'm going to change my Jenkins file, but I want to make sure I put it in the right place. So this is a bit tricky. When you do this for yourself, make sure you put it in before the last closing brace here. So it needs to be just after the publish stage. Cool. OK, so I write that. and add and commit it. Okay, so this will trigger a new build automatically. And what we should see is the deployment happens sort of seamlessly. So this is that continuous delivery pipeline that I've been promising. Let's see how that goes. So it hasn't picked up the change yet. It will do in a second. You notice that nothing else is actually running on my cluster. So we've got the new build there. There are no executors currently spun up. So MESOS will start to launch one in a second. And we should see that resource utilization increase in a minute. Cool. So we've got a new executor coming online there. And now it's running my build. Okay, so we've completed the deploy, and you'll see this new application here. So if I click on this little arrow here, if I go into the service and click on Open Service, it will refresh momentarily and actually serve my application. So we should see a Hello World thing come up here in a second once it's finished deploying. Not yet. I don't know how frequently our reverse proxy updates, but obviously slower than this. Okay, oh, that's interesting. Let's see if Clarence's one. So his works. Why doesn't mine work? There we go. Okay, so it took a minute. So that's the application being served. This is only available to authenticated users of the cluster. So this is not how you would make it available to the internet. That's actually the next exercise, but I will leave that as an exercise for you to do. I'll be around for the next 18 minutes. And these clusters are going to be online for another couple of hours. So if you feel like playing with them during your lunch break, go for it. One more thing I wanted to point out before I wrap up the sort of formal part of this is that my colleague Carl is speaking on POSIX for the data center. So he's going to talk about how you can use container orchestrators and these sort of new distributed systems, a bit including DCOS, how they basically provide semantics and primitives that you can use across your data center, a bit like POSIX. So I think he can probably do that more justice than I just did. I recommend checking out tomorrow at 3:50 in Tower Salon 8. So thank you for coming. I'll be around for the next 20 minutes or so. There are some stickers and business cards there. If you have any questions, come up and see me or raise your hand, I'll come over. Thank you.